Hi to everyone. So today we are going to learn how to design a battery charging system for a PV panel with the help of boost converter. So for this project we need to select first PV panel. So here I have used 200 watts PV panel. So the PV panel designs includes a series combination of arrays with the parallel structures. So the PV array consists of multiple solar panels connected in series and array parallel to achieve a desired voltage or the power output. So for this project, the array should be capable of delivering 200 watts. So therefore, I have choose the cell per number of cells per module is 60. The open circuit voltage is 36.3 and the short circuit current is 7.84 and the parallel strings 1 and the series connected modules per string is 1. So for the different irradiance level, we are getting the maximum power. So this is the PV and VI characteristics of solar panel. So the maximum power extracted for the 1000 irradiance level, so around 29 volt we are getting. The maximum power extracted from the PV panel is 213.15 watts. So this is a nearly 200 watts panel we have choose. So the open circuit voltage around is 36 point nearly 35.981. So this is the open circuit voltage. Here I have mentioned 36.3 volts. So we are getting the maximum power for the 1000 irradiance levels around what 213.5 for 1000 irradiance level. Then second one 800 irradiance level we are getting 171 watts. Then 600 irradiance level we are getting 129 watts. So these are the PV panel specifications. Then after that we have designed a boost converter. So here the input voltage is 36.3 volts. I have mentioned in open circuit voltage in PV panel. The output voltage is 48 volt because we have choose the battery is 48 volt. The rated capacity is 20 amperes per hour. Then the state of charge is 45. Then the battery response is what 1. We have choose that lead acid batteries. So based on the input voltage 36.3 and the output voltage is what 48 volt. So we need to design what boost converter. So normally DC to DC boost converter step up the lower voltage output from the PV array to the higher voltage required by the battery. It ensures the energy transfer and matches the PV output the charging voltage. Okay, how to design a boost converter? Based on the input and output, we have already discussed about how to design a boost converter in Simulink platform. I have added a video in link in description. Kindly go through it. So based on these requirements, here look at the requirements. So the input voltage is 36.3 volts, output voltage is 48. The maximum power is getting from the solar PV array panel. We are getting what 215 watts. We choose 5 kilohertz for switching frequencies. So based on the requirements, we are calculating the capacitance values and inductance values for the boost converter. So we are getting the capacitance values 0.0011 and the inductance value is 0.0015. These are the values are minimum values should record for designing a boost converter. So the equations related to boost converter we have already discussed. So now directly I move to the Simulink model. So this is the PV specs. This is the boost converter. This one is what battery storage. So we have already discussed about P&O MPPT algorithm. I have added a video link in the description. Can you go to it? So same algorithm we are going to use for to get the maximum power from the PV panel. So here we have choose the same 5 kilohertz and this is the P&O what we have followed in previous one. So if you have any doubt about how to design a P&O based MPPT, kindly go through my previous videos and post any comments related to your queries. The next one. So now I'm going to simulate the models. This one is a PV power. This one is the battery power. So we are going to set the irradiance level is 1000 fixed one and also the temperature is 25 degrees Celsius. So we are going to simulate the model. So it took few seconds to simulate the model. So based on our requirement, the 36.3 voltage is boosted to the 48 voltage and it is stored in the battery model. You can see that at initial stage the battery voltage is higher than the boost converter voltage. So therefore the battery is initially discharging. So therefore it's sourcing what? A positive current. So look at here, the battery is discharging. Then after that, when it is reaches a 48 voltage, the battery is ready to what? Charging. So we can see that if it is charging state, it goes to what? Negative current. So look at here, the current indicates what? Negative. And once the current indicates negative, the battery power also indicates what? Negative. So here we can see that the power is nearly reaches to 211.1 watts. So you can see the waveforms. It's perturbing and observing and reaches the maximum power. So this is the maximum current corresponding point of 29 voltage. It's nearly reaches the voltage is what? 29 volt. So you can see here the battery voltage, it is nearly equal to minus 4 amps. That is mean by the battery is what? Charging. So whenever the battery goes to negative values, it is indicates what? Charging. So you can see here that the battery voltage are also increasing. So when we start the simulation, it's nearly equal to 47.46 volt. Now it is getting nearly 47.53 volt. That is mean by the battery is what? Charging. So you can see the battery power extracted power from the battery. So we are getting nearly 200 watts. So if we are going to calculate the battery performance of the system, so this is the output power. Output power is nearly equal to 205 watts. This one is input power nearly equal to 213 watts. So calculate the output power divided by input power. We will get the what? Efficiency of the systems. Okay. So look at the PV panel. PV panel voltage. It's nearly reaches the maximum voltage of 29 volt, as we have seen PV panel. When it reaches the maximum power 213 volt, 213 watts, it is reaches. So this is the response of PV panel. So it is nearly reaches the 213 watts. When the maximum power reaches 213 watts, it's nearly reaches the voltage of nearly 29 volt. So we have seen here. So 29 volt, as I have mentioned earlier in PV panel, when it is reaches 213 watts, it is reaches nearly 29 volt. So this is the maximum power extracted point at this voltage. So it is nearly getting the current values 7.4 amps. So this is the response of battery. So at earlier stages, when the current is discharging, so from the period of 0.2, nearly 0.02, the battery is what? Discharging the level. So it is indicates the positive currents at the time the battery is discharging. Whenever the battery is discharging, at the period of SOC is what? Reduces. So it is indicates the SOC is reduces 45 to 44.9, it is gradually reduces. Whenever the battery is charging, the current goes towards negative. See here, the current values reaches nearly minus 4.25 amps. Whenever the current is negative, the battery is mean by charging, gradually increasing whenever the battery is charging. So nearly the output voltage, battery voltage is 48 volt, and the output current is nearly, the battery charge current is nearly 4.25 amps, and the output power of the battery is nearly minus 204 watts. So this is the simulation of P&O-based P&O MPPT for boost converter with the battery charging system. I hope you understand how to design a boost converter for a PV cell and how to store the boost converter voltage in the battery. I hope you can understand. Thank you for everyone.